All right, honor students, let's look at the ideal gas law problems level 2. So this is where we review what we know about the ideal gas law and how we are comparing a gas which we have in the lab to what we see ideally. So that means 1 atmosphere, 22.4 liters, 1 mole at 273 gives us our gas law constant of 0.0821 liter atmospheres per mole Kelvin. And then we put that into a version of the combined gas law in order to get the ideal gas law. So this really opens up a lot in the chemical world. But one of those that ends up being important to point out before we go any further is you have to be in the right units. Okay, volume must be in liters, pressure must be in atmospheres, your amount must be in moles, not grams. So don't try to take the easy way out and just plug in a mass. Okay, temperature must be in kelvins. So since there are so many different variables at play here, we can start to incorporate much more about our gases. We can incorporate things like density and determining identities through molar mass. So quick review from what we did all the way back in the first couple of chapters is density. Remember, we love it. Mass over volume, okay? In gases, since we are dealing with our volume in liters, you'll see it's in grams per liters. Before, when we had solids, it was usually grams per milliliters or cubic centimeters. And as always, we have our molar mass in grams per mole. So hope you have your periodic tables handy. Okay, so let's take a look at this first problem here. It says an elemental gas, pretty important, an elemental gas has a mass of 10.3 grams. If the volume is 58.4 liters and the pressure is 758 torr at a temperature of 2.5 degrees Celsius, what is the identity of the gas? So who is this? That's what we want to know. So let's figure out what we do know. All right, P, V, N, R, and T are always there for us. And we know the gas law constant is 0.0821 liter atmospheres per mole Kelvin. Okay, we have 58.4 liters. We have 758 torr, which we will convert, and a temperature of 2.5 degrees Celsius. The problem did not give me N. The problem gave me a mass. So that's going to be something I'm going to keep over here, where M stands for mass, not just ASS, MASS, of 10.3 grams. So how can we figure out the identity of a substance? We can figure out the identity of a substance through its molar mass. Molar mass is grams per mole. Okay, so if I have grams and I can figure out moles, I can just do a side calculation and take 10.3 grams divided by however many moles is, and then take a look on my periodic table to see who this element must be. I can do that. You can too. All right, so let's plug in. PV equals nRT. We're going to solve for N, so divide both sides by R and T. So we get N equals PV over RT. R's and T's cancel out. So my pressure is, hold on, we forgot. Our pressure has to change to atmospheres. So 1 atmosphere is 760 torr. So if we take 758 and divide by 760, that's when we get 0.997 atmospheres. And while we're at it, 2.5 degrees Celsius is equal to 275.5 Kelvin. Okay, so back to plugging things in. 0.997 atmospheres times 58.4 liters, R 0.0821 liter atmospheres per mole Kelvin, atoms per moles. And then we have 275.5 Kelvin. And that will give us N. Okay, my number of moles. Atmospheres and atmospheres will cancel out, liters and liters will cancel out, Kelvin and Kelvin will cancel out. I'll get 1 over mole, or inverse moles, which will be in moles. Yay! So let's put this in the calculator. That is 0.997 times 58.4 divided by 0.0821 divided by 275.5 equals. And we get 2.57 moles of my elemental gas. Okay, so now I have moles, but I want to know the identity. So I plug this in down here. 2.57 moles. So I can figure out the identity of my elements through their molar mass. So 10.3 divided by 2.54 is going to give me 4.00 grams per mole. And now we go hunting on our periodic table which elements, which are in red that we colored, which means they are gas um, in normal conditions. Okay, hydrogen has a molar mass of 1.008. Helium has a molar mass of 4.0. Oh, then that must be helium. Hee hee hee. Yes, indeed. That's how you can figure out who the gas is when you have all of these things in your ideal gas law. So to review, in case you couldn't read my writing, 0.997 atmospheres, 28.4 liters, okay, and we have our 0.0821 liters per mole Kelvin. Our temperature is 275.5, our mass is 10.3. So we are looking for the identity. So we pull up the molar mass and check it with the periodic table. So we plug into our ideal gas law, solving for N. N equals 2.57 moles. Then we change, or we convert our 10.3 grams, we divide it by 2.54 because that's the ratio. Grams per moles is our ratio for molar mass. And we get a molar mass of 4.0 grams per mole. And then according to our periodic table, the only elemental gas with a molar mass of 4.0 is helium. And that's how we can work with those extension of our ideal gas law problems.